Now we're going to continue our discussion of force components. We talked about two specific examples of force breaking down vectors into its components, a 3, 4, 5 right triangle and a 45, 45 or isosceles triangle examples. However, many vectors are not oriented at those specific angles and create those specific triangles. So trigonometry one form of mathematics will become quite useful here to analyze vectors of any angle. So let's introduce sine theta, theta being an angle. Um, this trigonometric function is defined as the opposite side of a right triangle divided by the hypotenuse. Cosine theta is another trigonometric function, and it is the side adjacent to the angle theta divided by the hypotenuse. So these trigonometric functions are in your calculator and are very useful in helping us find the y and x components. Oh, okay. So let's say we have a vector A, and it's 10 newtons large, and the angle theta is 60 degrees. Can we find out how big these y and x components are? And the answer is yes. So let's go do that. Okay, so let's say we have a vector, again, 10 newtons at 60 degrees. Can we analyze how big the x and y components are? And the answer is yes. Okay, so again, as a reminder, we have these functions, cosine and sine. Cosine theta is equal to the adjacent side divided by the hypotenuse. Okay, so if we were looking for the x component, we actually can take, in this case, the cosine of 60 degrees. That's our angle in this case. And the adjacent side is the x component, which we're looking for. And that gets divided by the hypotenuse, which we know is 10 newtons in this case. So the cosine of 60 degrees is something you can find by just typing it into your calculator, and you find that it's 0.5. And the x component we don't know, but again, we're dividing it by the hypotenuse of 10 newtons. So we're just going to simply do some algebra here. We're going to multiply both sides by 10 newtons. And the 10 newtons cancels on that side. 10 newtons times 0.5 is 5 newtons, and that's the value of the x component. Okay, so now let's find the y component. Well, we have another trigonometric function, sine theta, and that's equal to the side opposite the angle divided by the hypotenuse. Now, in this case, it's 60 degrees, so we'll put in specifically 60 degrees. The opposite side happens to be the y component, and the hypotenuse is 10 newtons. Okay, we can simply do some algebra here to solve for the y component, but you first have to find the sine of 60, which is 0.866 in your calculator. All right, let's do some algebra to get rid of the 10 newtons. And the y component, if you round off, is equal to 8.7 newtons, 0.866 times 10. And so now we have a value for how much y there is in this original vector, the y component, and how far this vector goes in the x direction, or the x component, 5 newtons. Thank you for listening.